Hello students, in this video I will discuss Biot-Savart's law. As we know, when current passes through a conductor, suppose this is a conductor and current is passing through a conductor. When current passes through a conductor, in its surrounding magnetic field is produced. Okay, when current passes through a conductor, in its surrounding magnetic field is produced. This we have learned from Orsted's experiment already. Now, how much magnetic field will be produced? Suppose this is a point here. Now, what is the magnitude of the magnetic field? That is not given in Orsted experiment. Okay. Biot-Savart's law will give us how much magnetic field is produced at this point. Now, we have taken a small portion of the conductor. Okay, the length of the conductor is suppose dl. Length of this portion is called dl, which is known as length element. Now, for this element, what will be the magnetic field at this point? Suppose this point is P, and we want to find magnetic field at point P due to this small segment dl. The distance of point P from this dl is suppose r. You can put a vector, so r vector is the position vector of P with respect to dl. dl is say at point O, you can call this point as O. Okay, and theta is the angle between this ideal and r. R is the position vector, and this ideal, this is called the current element. Ideal is called the current element. It is a vector quantity. Okay, the length of the small segment into current. And what is the direction? Direction is same as that of the current. R is the position vector. R is the position vector of P with respect to ideal. Theta is the angle. Angle between what? Ideal and R. Theta is the angle between ideal and R. Suppose dB is the magnetic field at P due to ideal. Because of this segment, what is the magnetic field here? Say dB is the magnetic field. Generally, magnetic field is represented by B, but since the length is small dl, so magnetic field will be small dB. B is the magnetic field, dB means small magnetic field. L is the length, dl means small length. Since the length is small, so the magnetic field is also small. Now, according to Biot-Savart's law, this magnetic field depends on what? The magnetic field dB is directly proportional to the current. More is the current, more will be the magnetic field. Okay, it also depends on the length. So directly proportional to the length. More is the length of the conductor, more will be the magnetic field. If you combine, we can say magnetic field is directly proportional to current element. Ideal is called current element. Okay, just you think individually. When the current is small, obviously magnetic field is small. The magnetic field is produced due to what? Due to current. Okay, when current is small, magnetic field is small. When current is large, magnetic field is large. If current is zero, then magnetic field will be zero. Similarly, when the length of the conductor is large, the magnetic field will be more. When the length of the conductor is small, the magnetic field will be less. So we combine this dB proportional to ideal. Now, dB is also proportional to sine theta. Okay, this angle is called theta. Okay, now it is found mathematically by experiment. We found that dB, the value dB varies with sine theta. Sine 0 is 0, sine 90 is 1. So when theta is 90 degree, the dB will be maximum. When theta is 0 degree, dB will be minimum. Okay, this we have found experimentally. Next, dB, the magnetic field, also depends on distance. So obviously when the distance is more, magnetic field will be less. When distance is less, magnetic field will be more. And it is found relation is dB proportional to 1 by r square. Means when distance increases, magnetic field decreases very rapidly. Now combining these, we have dV proportional to ideal sine theta by r square. In place of proportional, if you put is equal to, then you have to put a constant. Here the constant is mu naught by 4 pi. In SI, in vacuum, the constant is mu naught by 4 pi. Then ideal sine theta by r square. Okay, the value of this experimentally found to be 10 to the power minus 7. Okay, this is experimental. Okay, this is experimental. dV equals to mu naught by 4 pi ideal sin theta by r square. What is the value of mu naught by 4 pi? 10 to the power minus 7 Tesla meter per ampere. So this is the mathematical form of Biot-Savart's law. So when you are asked to write Biot-Savart's law in the exam, the question will be write Biot-Savart's law. So you will write this one: dV equals to mu naught by 4 pi ideal sin theta by r square, where what is I, what is dl, what is theta, what is r, you have to mention. Only this 1 mark you will get. You need not to write all these things. Okay, you need not to write all these things. You just write according to Biot-Savart's law this: dV equals to this, and you have to mention where ideal is current element, r is this, theta is this, dV is this. Okay, but in the exam you will get vector form of Biot-Savart's law. It is more frequent. Okay, you will be asked to write vector form, Biot-Savart's law in vector form, not this, but the Biot-Savart's law in vector form. What is the vector form? You simply write. Okay, no need to prove, you have to simply write the formula. The formula is dB vector equals to mu naught by 4 pi I dl vector cross r vector by r cube. Okay, so Biot-Savart's law in vector form is dV vector equals to mu naught I by 4 pi dl cross r by r cube. Now comparison between Biot-Savart's law and Coulomb's law of electrostatics. Now similarities between Coulomb's law and Biot-Savart's law. The first similarity between Coulomb's law and Biot-Savart's law, you see F is inversely proportional to r square, so depends on distance, long range force. Here dB also proportional to 1 by r square. Okay, this is the first similarity between Coulomb's law and Biot-Savart's law. It is a long range. So the first similarity is long range. Now this electrostatic field is produced by this charge. Okay, these charges are scalar quantities. So we can say the electrostatic field, in this case the source is a scalar source. For Coulomb's law electrostatic field, the source is a scalar source. Why? Because the electrostatic field, the force is produced by these charges, and charges are scalar quantity, so the source is electrostatic source. So electrostatic field is produced by scalar source. Now you come to magnetic field. Here the magnetic field produced by what? By this current element ideal, and this ideal is a vector quantity, so we can say that the magnetic field is due to what? Vector source, because the magnetic field is produced by this ideal, which is a vector quantity. Thus magnetic field is produced by the vector source ideal. Now the next difference is, you see these are the two charges. Suppose the two charges are similar charges, then they will repel. The force will be what? The force will be along this line. You see, the force will act along this line, the line joining the two charges. Okay, displacement vector. So displacement vector and force are in the same direction, along the same line. It may be away, it may be towards, but in this case this is the line joining this vector, displacement vector, but the magnetic field is always perpendicular. Okay, magnetic field is what? Magnetic field is perpendicular to this r. Magnetic field is perpendicular to this r, because what is dB vector? dB vector is mu naught I by 4 pi, right, dl vector cross r vector divided by r cube. Now according to cross product, you see dB vector must be perpendicular to dl and r. This is the rule of cross product. Fine, it is the rule of cross product. Okay, the result must be the perpendicular to the plane containing these two. So dl vector and r vector is lying in a plane, and dB is perpendicular to that. Okay, so what is the difference between Coulomb's law electrostatic field and Biot-Savart's law magnetic field? in electrostatic field, the force is along the line joining the two charges along the displacement vector. But here the magnetic field is perpendicular to the plane containing dl, displacement, dl and r, okay, current element and displacement. So we can write electrostatic field is along the line joining the two charges. Magnetic field is perpendicular to the line joining the perpendicular to the plane containing r vector and ideal. Okay, the final difference, you see, in Biot-Savart's law, the field here depends on theta, angle. Okay, if the angle changes, the magnetic field will also change, dB proportional to sine theta. So when the angle changes, the magnetic field will change. But here the force does not depend on theta. Okay, here the force does not depend on theta. Electrostatic field does not depend on the angle, but Biot-Savart's law, magnetic field depends on the angle. Thus, electrostatic field is not angle dependent, but magnetic field is angle dependent. Okay, so this is all about Biot-Savart's law. In the next video, we'll discuss the application of Biot-Savart's law. Okay, thank you very much.